Welcome. In this presentation, Kim Losi hosts several speakers who discuss Autodesk's advances in 3D printing. First, Kevin Tracy talks about Spark, a platform for manufacturing, and also the Spark Investment Fund, which promotes the development of additive manufacturing technologies. Next, Pierre Lin talks about Ember, Autodesk's new 3D resin printer. He reviews Ember's progress over the past year and begins a demonstration of high-speed printing. Then, Chris Pruscia, CEO of Origin, announces custom 3D printed smart tags that they produce on an array of Ember printers. Then Pierre returns to reveal the results of the high-speed printing demo. He also discusses Ember's open source resin and how it has led to innovation. The last speaker is Corey Bloom, who announces Project Escher, a technology that orchestrates multiple FDM extrusion heads that in unison print large, detailed parts very quickly.
Okay, good morning, everyone. Welcome to Autodesk Pier 9. I want to thank you, first of all, for being here. In this room, we have several members of the media, but we also have several members of the Autodesk team. So it was really important for us. This is one of the first times that we're really telling the whole story about some of the things that we've been doing to help advance 3D printing. So we wanted to do that across our internal teams, but we also wanted you in the media to be part of that, hearing that message for the first time here with us as well. I am Kimberly Losi. I'm a marketing manager here at Autodesk, and I've been part of many of these projects that we'll talk about today. And before we get started, though, I just wanted to kind of set the stage really quickly. We spend a lot of time working in the future, so I think it's always important to remind myself, at least, where are we today? It is March 3rd, 2016. And we're here at the Autodesk Advances in 3D Printing event. So 3D printing and additive manufacturing. Throughout the morning, you're going to hear us use those two terms interchangeably. I just want you to know that we do mean the same thing. It's really the process of creating a product by adding material to it versus taking it away. And then finally, I just want to touch on the importance of additive manufacturing for Autodesk as a company. I'd like to show you an example, really, of what we mean. It's about the future of making things. And that really, here on the left, you see an image of, this was a collaboration between Autodesk and Airbus to create this new airplane divider. So it's basically about taking really advanced software solutions and really advanced manufacturing solutions to create an optimized end result. So this partition ended up being not only stronger, but more lightweight. So you can imagine the possibilities for customers that are producing hundreds or millions of anything. The really awesome part about this, I guess, though, is there was clearly an advantage for Airbus. It was great for us as well, but this is a problem that's facing all of our customers. Everybody's looking for innovation and advanced design solutions, and as a company, we need to make sure that they have advanced manufacturing, or that we're helping to drive innovation so that they have advanced manufacturing solutions to be able to bring those products into real life. Okay, so what can you expect this morning? 3 things. We are going to talk about how Autodesk is investing in 3D printing with the Spark Investment Fund. We are going to talk about contributions with an open system. So we have made some new advancements. We've unlocked, some new capabilities with Ember, and we also want to share with you some of those capabilities that have been unlocked by our partners. And finally, we have a brand new development that we're going to share here for the first time today. It's a solution for allowing customers and partners to print at scale. So now I'm going to turn it over to Kevin Tracy to give you a little bit of background on Spark and the Spark Investment Fund.
Hi, everybody. Before we jump into the discussion about the Spark Investment Fund, I think it's important to go back and take a look at what was the genesis of Spark. Why are we here? What do we do this for? Fundamentally, the 3D printing's been around for a while. It's almost 3 decades old at this point. But as we look back over the past 20 plus years, there's not been a huge amount of innovation. And when we look at why that is, we look at a situation where there's essentially a series of very closed ecosystems where one hardware system works with one software system, works with one material or a handful of materials. This has been prevalent for the last couple of decades and has not allowed a lot of innovation in the market. So what Autodesk has said is, take for example the materials market. There's hundreds of years of experience in materials out there, yet none of these companies have the opportunity or the ability to get into this market in its current state. So what Autodesk did is we stepped back and said, what do we need to do to solve this? And the core component we felt was a software platform that allowed everybody to talk with everybody. Fundamentally, that's what Spark is. It's the core layer that says, whether you have a software application, a hardware application, or materials, or a new material, you can play with each other. Right now, the way the market works, if you go back, you have to do a deal with every particular hardware company, try to do a deal with the software with materials company, and then patch together a series of software applications. This is constraining to the market in several ways because, first of all, these folks on the outside of the material space, they haven't developed any new materials in a long time because they have no access to the market. So as you as an entrepreneur want to bring a new machine to the market, you have to develop your own materials. You have to develop your own software. This is a huge impediment to getting to the market, and actually it eats up a large amount of the investment from a startup. So when you look at Spark, how does it solve that? You have design, and then you have the output of design, which is actually the object you want out of the 3D printing process. What Spark does is it fills in the gap in between. All those disparate applications you currently have to use that maybe from 5 or 6 different vendors are all embedded in the platform and are usable by anybody who just wants to call a simple API. This allows people who currently don't have the development ability or the capability to develop a software stack that can power a printer to do so. And also it enables open and free use of new materials, as Pierre will go into when he talks about the Ember and Escher. And how does this help everybody? So right now, all these folks have different levels of access to the market. By creating a common platform, it gives them a common way to access and basically a growing and increasingly great opportunity in the AM space. So this was part of the goal we had, which is develop a basic platform that allowed everybody to play and everybody to access the ecosystem. The other issue was, how do we spur innovation in this ecosystem? And that's what the Spark Fund was about. The Spark Fund was put together. It's a $100 million investment fund. We have no preconceptions about doing certain investments at early stage, late stage, mid stage. We're open to all the above. And part of this is to basically say, okay, how do we drive innovation back into this market? We're not just going to invest in any random company because it is a potentially good financial return. It has to match the ethos of what we're trying to do, which is, does it drive innovation in the market? Does it have a strong team? And does it allow open and kind of easy access to new materials, new software, or new hardware? And kind of putting our money where our mouth is, we've done several investments over these last year. A couple I'll highlight here. One is Voxel 8, a very innovative materials and hardware company. They basically allow for the 3D printing of not only traditional plastic materials in this current iteration, but also circuits and circuit design. So you have the ability to, as you saw in the video, literally print a drone, drop in the electric motors for it, and hit go. That's potentially a game changer in this world as we move forward into fully integrated manufacturing processes. Another investment we made was in Optimec. They're an interesting company that has everything from national laboratories as customers all the way up through Google and the kind of stars of the tech industry. What you see there is actually a conformal antenna printed on a golf ball. And if you understand the complexities of that, it becomes a really interesting thing where you can now print conformally conductive materials basically around an object. So as we go into the Internet of Things, they have the industrial Internet of Things. You have the object ability to now add sensors to previously inanimate industrial objects, such as a turbine blade. They also do what's called a lens system, which is a direct deposition metal process, which allows you to add metal to not only a new object or create a new object with it, but kind of address repair and other processes on a current object. So you'd be able to measure a turbine blade, figure out where it was currently broken, add material, and then repair that blade directly in the machine. And this all leads to why we're here today, which is basically to announce that we've made another investment in a very unique company in Israel called XJet. The investment is part of a syndicate of investors. We invest $25 million, and the goal is to help drive this company's innovation forward to market. This is a process that currently has no equal in the market right now. It's a nanomedical metal particle deposition machine, which basically means you're going to be able to get, with minimal post-processing, extremely high precision parts with high levels of surface finish. This is something that you can't find in the market today. And part of what we're doing with Spark and the investment fund is to do just this, which is to help these guys get to market, to drive innovation and drive new technologies back into this ecosystem. And with that, I will turn it over to Pierre. Kim.
Me again. Thanks, Kevin. So what Kevin just shared with you are some of the challenges that we're trying to help overcome in the additive manufacturing space, and also some detail on some of the most recent investments. So investing in Voxel 8, printing electronics, and now nanometal printing with XJet. One of the first steps that Autodesk took in the hardware space was actually to create the Ember 3D printer. So I'd like to invite Pierre Lynn up, one of our principal engineers. Pierre is going to share with you some more details and also unveil here for the first time a little experiment that we've been working on.
So yeah, thanks Kim, and hey everyone. So it's been about a little over a year since we released the Ember 3D printer. And so we just wanted to give you a quick update on who's been using it and what they've been using it for. But before we do that, in the spirit of openness and innovation, I'm going to run a little quick experiment here today. So as you can see, we have two machines, two Embers up at the front here. The Ember on your right is an Ember that's just a standard out-of-the-box configuration. And it's printing this part, which represents the full build volume of Ember. So it's got probably about 9 hours left to print, and I started it off this morning about 7 a.m. So this highlights one of the challenges of 3D printing, which is speed. It takes quite a lot of time to print objects. But one of the cool things about Ember, and one of the really exciting things about Ember, is that it's an open system. And that means we give our customers access to all of the material, software, firmware, and printer settings, so they can optimize it for their workflows. So with this second Ember, which by the way is exactly the same hardware, what I've done is I've made a few optimizations to the software and materials. And what we're going to try and do is print the same part in less time than it takes to finish this presentation. So it's going to be a little bit exciting. We'll see what happens. But here we go. And by the way, it starts off slowly, so it sort of builds up. Okay, let's get into the update. So firstly, just a reminder of what Ember is. Ember is a high-resolution DLP stereolithography 3D printer, and that means it prints in a liquid photoresin that is cured by light. We launched it as a reference design for our Spark 3D printing platform. Think of it as the Nexus phone to the Android platform. It allows us to explore the intersection of hardware, software, and materials in real-world applications. There's nothing like putting a product out on the market and seeing what customers do with it to get real feedback on what you're doing. But we also wanted to give those customers the ability to explore the intersection of hardware, software, and materials, and so we decided to make it open source. So how have we been doing? Well, as some of you may know, our CTO, Jeff Kowalski, has been pretty forthright in the past on his opinions of 3D printing. He's called it out several times for having very high failure rates, up to 75%, and generally sucking. So, no pressure, guys. So one of the first decisions we made is that we decided to build analytics into Ember so that we could measure our print success rate. So for customers that opt in by connecting Ember to our platform, after every print, we ask them, was your print successful? And so here's the data. You can see that the first 10 months, make for pretty sobering reading with very low success rates. And what we realized after speaking to customers and getting their feedback is it's not enough just to have a good piece of hardware. What you really need is you need that full connected ecosystem of hardware, software, and materials. So what we did was that we made some changes to the software and materials to address some of those earlier shortcomings. So notably, the Spark team released Print Studio, which is a much more advanced print preparation software to address some of the issues on the design side before you start printing. Our polymer chemist developed a new resin formulation, and we overhauled the printer firmware to increase reliability. But we still have work to do. So how are we going to get to that 100% success rate, which is where we want to be? Well, we're going to continue this approach of developing a connected ecosystem of hardware, software, and materials, because our experience of the last 15 months has demonstrated that that is a valid approach. By more tightly integrating hardware, software, and materials, you can increase the print success rate. But what I think is going to be crucial to get to that 100% success rate is that you really need to give your customers the ability to build their own workflows, because really, they're in the at the coal mine doing the manufacturing. They really understand what the manufacturing problems are, and they're best placed to develop solutions for those problems. And this is exactly what the Spark platform will enable. So now I'd like to invite Chris from Origin to share with you a customer story about how a local company are leveraging the open ecosystem of Ember to develop their own workflow and manufacture custom consumer goods using Ember.
Thanks, Pierre. Hi, I'm Chris Bruchet. I'm one of the founders and the CEO of Origin. And getting a new product to market is extremely challenging. You need to design the product, you need to prototype it, and you have to manufacture it before you can even think about selling it. While design tools have improved tremendously over the years, thanks to companies like Autodesk, prototyping, particularly manufacturing, remain elusive. So traditionally, prototypes were made by hand. And this was overall really nasty, sort of painful part of the whole process. And this all changed in 1983. A man by the name of Chuck Hull, who was frustrated with designing new products and prototyping those designs, set out to solve this very specific problem. The result, just a year later, was the invention of the 3D printer. A few years after this, he introduced the SLA-1. It was the first 3D printer you could buy. This would change how the world prototypes products forever. So, next slide. 3 decades later, we've shrunken 3D printers to fit on our desks, and there's been all this hype around 3D printing, especially with futurists and those in the maker communities, about revolutionizing both making and manufacturing, and that we may enter a new industrial revolution. And for manufacturing, this industrial revolution could blur the line between one-off prototype and mass production. So in essence, making hardware could be a lot more like making software. I mean, imagine rapidly iterating product designs, A/B testing these designs, allowing customers to infinitely customize their products, and even manufacturing objects that you can't make with traditional methods. Doing all of this without the penalties of current traditional manufacturing technology, no tooling, etc. So this is the promise of 3D printing and manufacturing. But unfortunately, over the last few years, despite the new hype in 3D printing, the industry as a whole sort of failed to make good on this promise. Can we only dream of a world filled with 3D printed products? Or is it something that we can actually do something about and solve? So, at Origin, our mission has been to make manufacturing simple instead of the currently complex, frustrating, risky endeavor that it currently is. We knew that 3D printing would be a key part of creating overall simple manufacturing experience for customers. So the first problem we had to solve was choosing the right 3D printing technology to start with. So we started by looking at the entire market of desktop 3D printers. I mean, forget manufacturing. As Pierre said, most of these printers fail to reliably print a single part, and also the quality is not too good. So manufacturing is just out of the question for these printers. So then we turned to industrial printers, which have been around for about 30 years. And we found they actually still have many fatal flaws. Many of them are locked to materials. This increases the cost of making parts on these printers because the companies that make the printers make money from the materials. And also, the software and the hardware is completely closed. So it's difficult to use these printers for more than they're originally intended. So ultimately, you're sort of beholden to the companies that actually make the printers. So it's no wonder with all of this why we don't have a 3D printing revolution. I mean, where do you start? So then we found Ember. As Pierre mentioned, Ember has DLP SLA technology. This technology allows Ember to be competitive in quality with injection molding today, as you can see with all the beautiful parts over there. Another advantage is it doesn't cost the price of a house, which is what some of the industrial printers cost. And the most important fact of Ember is that it's open. So you can build on top of it. So after we discovered Ember, we started experimenting with it. We started to dig into its open architecture, and we tried to remove a lot of the things you need in traditional manufacturing, and even some 3D printing processes. Things like sanding, blasting, ultrasonic welding, and even assembling products. The result of this, after a few months of building new processes, hacking software, writing our own, and experimenting with tons of materials, was the ability to create complete products that look as good as a commercial product. And the challenge after that was to ship these products to customers in volume. So Marshawn Lynch's limited edition Beast Mode shoe, it was a few weeks, there it is right there, Kim's handing around. It was a few weeks away from shipping before Black Friday. They weren't happy with the limited edition Bluetooth smart tag that was created by a traditional manufacturer over many months. So in just 2 weeks before these shipped, before the holidays, we manufactured 3D printed smart tags on just 4 Ember printers. And it allowed Beast Mode to ship 500 limited edition units on time. And ultimately with the smart tag that looked and worked the way they wanted. So when you think about it, we did this in the length of time it would take to ship something from the Far East and get it through customs, let alone manufacture it there. So you can see the smart tag right there. The really cool thing, interacts with your iPhone to unlock special content and tie that particular shoe to your digital identity in their app. So this was all a huge breakthrough. But we soon realized that speed wouldn't be the only advantage of manufacturing with Ember and 3D printing. So lately we've been working with many other companies. One of those, Chronicled, has been creating these tags that attach to sneakers, luxury goods, etc. We use near-field communication technology. And what they ultimately do is guarantee the authenticity of the good that it's attached to. And it uses the blockchain, which is the primary thing that powers Bitcoin, to attach your digital identity to that merchandise. And I want to show you real quickly what our manufacturing process for these tags looks like today on stock Ember hardware with just process and software changes. There's the tag.
Here's how these tags are made in Origin's production lab. They are printed in 3 stages: the main body, the base, and the logo. They send the print file for the main body to an Ember. The build head lowers into a tray of red colored resin. The part will form on the aluminum face of the build head. Blue light from beneath the tray prints the first layer. The tray slides away and back again to print the next layer. 35 layers, and 4 minutes later, the build head rises from the resin and the main body is finished. On one side there is a rim. This is where the microchip is inserted. In production, the part is left on the build head and the chip is inserted in the upside down part. Now they send the print file for the base to the Ember. It will print directly over the chip, completely encasing it in plastic. This print file also includes the serial number. Origin software uses Ember's open source architecture to generate a unique number for each print file. After this print is finished, they remove the build head from the Ember and take it to a press, where they slide the parts off the build head. They 3D print a fixture on a build head that fits the tag bodies, which ensures alignment when printing the logo. The build head goes back onto an Ember, this time with white resin, and the logo is printed in about 2 minutes. They remove the tags from the fixture, clean them, and after a quick UV cure, they have a final product. Using this procedure, they had only one failure in a run of 600.
So as you can see, by building a custom process around Ember, we get that failure rate to basically 0. And we can actually manufacture with the out-of-the-box hardware. And we now produce these in quantity. We have 10 Ember printers, and we can print thousands of these, maybe even more in a week as we continue improving the process. The advantage of making these with 3D printers, especially the Ember, is the fact that Chronicle, the customer, can white label these. And I think Jen's passing some around the audience. And basically, Chronicle can white label them with different brands, retailers, with totally different designs and color schemes. And we can print them in just a couple of minutes. And we've been able to do it inexpensively enough that they can speculatively send these out to different brands and retailers with their custom logo, get feedback, iterate a few different designs, and then close a business-to-business deal where they then pilot with 100 units and potentially order thousands of these units. This is a strategy that Chronicle claims has achieved a 50% conversion rate in their business development program. And this is incredible when you think about it. You can't do this with traditional manufacturing. We've opened up an entirely new way to do business just by using this 3D printing manufacturing process. And so, lastly, I'm proud to announce that we're accepting early signups for Origin's manufacturing platform. So our platform is designed to give customers access to the future of manufacturing, unlimited design iterations, product customization, and the simplified manufacturing experience from anywhere. All of the manufacturing is taken care of for you. This is essentially an interface to the next generation of manufacturing. And of course, it's going to integrate with all of Autodesk's APIs, Fusion 360 for viewing 3D models, as well as Spark for integration with both design and the actual back-end manufacturing process. And we realize it's going to take more than just us to start this sort of next industrial revolution. So we're now going to welcome other additive manufacturers and eventually open our process, our technology, and our innovations to them so that they can manufacture real products with Spark-enabled printers on our platform. We believe that companies like Origin, Autodesk, other additive manufacturers, everyone in the maker community can work together and truly create the next industrial revolution with 3D printing. So I think I'm going to turn it back to Pierre here.
So thanks, Chris. And so just to briefly recap, what you just saw was a really cool example about how an open ecosystem can drive innovation in manufacturing by giving the customer the tools to develop new processes. New processes open up new business models and new business opportunities, as well as greatly improving the print success rate. So Origin were able to achieve a success rate of very close to 100%. And this was only possible because they had access to all of the machine settings, the software settings, and the full range of materials that are available on the market today. So, but before we check in on our experiment, which has just finished, I also want to share with you how our research customers have been experimenting with Ember. So let's talk a bit about materials. As Kevin mentioned earlier, one of the challenges facing additive manufacturing is that there just aren't that many material options available. If I were to design a part for injection molding, which is the process used today to manufacture most, consumer plastics or large-scale plastic parts, I have thousands of materials to suit every application. So on this slide here, you can see a chart that shows you the material space of traditional manufacturing and all the different options that you have. But when you look into the additive manufacturing space, you're actually limited to only a handful of different materials. And this really severely limits the applications, the application space for additive manufacturing. As an open system, Ember is driving innovation in this area by giving the customers the ability to experiment and develop new materials. But we thought it wasn't enough just to have an open system. We needed to provide a starting point for companies to develop upon. And so that's why last year we decided to open source our first resin, which was Autodesk Standard Clear, to provide companies with a starting point for developing their own materials and to accelerate materials development in the additive manufacturing market. And surprisingly enough, an Ember customer did just that. So Teton 3D developed a porcelain ceramic photoresin called Porcelite, and they started from Autodesk Standard Clear. So they spent several months iterating through numerous formulations to create a fully ceramic resin straight from the 3D printer, which can then be fired to create a 100% porcelain object. And this is actually really cool because ceramics have tremendous engineering properties, as well as being used in lots of different consumer goods. And really, it's materials development integrated with a connected ecosystem of software and hardware that's going to drive additive manufacturing into new markets and open up new business opportunities. Okay, let's now check in on the experiment. So I think people in the front can see that it's finished. It worked, which is always great. Live demos are always exciting. But what you just saw was this part being printed 24 times faster than in the standard out-of-the-box configuration. And as a reminder, the hardware between these two systems is identical, and all I did was optimize the software and materials. So why is this important? Well, it's actually, first off, it's pretty cool to see a part materialize in minutes right in front of your eyes. But secondly, as I mentioned earlier, speed is one of the big challenges that is facing the additive manufacturing market. And if we can produce objects more quickly, we're going to open up new opportunities to produce, use additive manufacturing in production. And finally, if you're going to really drive innovation in manufacturing processes, you need to work on the whole ecosystem of hardware, software, and materials. You can't just take one piece. Everything needs to be integrated together. Otherwise, you're never truly optimizing the whole process. So, why is Autodesk doing these kind of experiments? Well, we want to continue advancing the state of the art in additive manufacturing because we want to be able to solve our customers' challenges, and they have exactly the same challenges like this. And also, today we just wanted to sort of educate people about how Ember is a great, not only a great manufacturing tool, as Chris demonstrated, but also a great research tool, because it is open and it gives people the ability to explore the limits of the current technology. Of course, there are some limitations to printing at this speed, and today we've published some research where we explain those limitations. We explain how to configure Ember to print at this high speed, and also what future work could look in this space. So now I'm going to hand you back to Kim, who's going to introduce another project that we've been working on.
Thanks, Pierre. Okay, so there's a lot of information there. What we just saw was that Ember, being an open system with connected hardware, software, and materials, is able to be customized to improve the success rate for customers in the manufacturing space, to actually take prototyping to a whole new level of manufacturing. You're seeing Ember with not only an open resin tray, but open access to all of its settings and a released resin formulation driving new materials development. Here we talked about Teton 3D, but we also have several customers in the research space that are doing additional development of different bio-inks and things like that. And then you saw how when your system is totally open, you can use it to do really things that weren't possible before. So we just took the standard configuration of Ember, made a few changes, and all of a sudden it's printing more quickly. So what's next? Ember is an amazing machine. It's great at a small scale when you're looking for really high precision. But when we start looking at Autodesk's customers, think about aerospace, automotive, and building. It's probably not this technology. So we look at other technologies where we're really able to build big. And I want to introduce now Corey Bloom, who's our lead engineer that's going to share with you today a brand new technology that we're unveiling publicly for the first time.
All right, thank you, Kim. As Kim and my other colleagues have mentioned and demonstrated, at Autodesk we're working on many fronts, pushing the state-of-the-art of the entire additive manufacturing industry. And to do that, we're tackling some of what we consider to be the industry's most important challenges. Project Escher, which is a code name, is a new technology that combines software and hardware for unprecedented speed, scale, and detail in extruded prints. Unlike resin-based Ember printers, Project Escher focuses on printing methods like FDM that require pushing material out of a nozzle. Historically, the challenge with additive has been that it's impossible to combine large scale, high speed, and fine detail. You'll notice the void in the Venn diagram in the middle. Until very recently, you could have one of these, occasionally two, but never all three. For example, the Ember printer is very detailed and now very fast, but it makes small parts. Conversely, big extruding FDM machines are either extremely slow, sometimes spending days to make a print, or they use large nozzles and make coarse prints. But until Project Escher, prints made by extrusion were never big, detailed, and many times faster than what is otherwise possible today. So let's see Project Escher in action. Somewhere down here there's an arrow, I've been told. I'm going backwards and sideways.
A lot of why things haven't developed to kind of the hype and a lot of the excitement around 3D printing is that there's been to some degree an undue focus on the actual hardware, and a lot of the software has kind of been left behind. Should the same software that's making a hip implant also make airplane parts and also make bottle openers? You only have one nozzle, describing the entirety of an object. It takes a very long time to produce objects of, more industrial scale. What makes Escher special is its ability to enable collaborative fabrication between a number of tools to describe that geometry in parallel. And when you start getting into abilities to parallelize fabrication, that dramatically reduces the time and cost of a lot of these geometries.
We're building a very flexible industrial system. It's not just limited to additive. It has the potential to be able to do subtractive technology. There'll be tool changing, so you can switch tool heads, you can do hot staking, you can do pick and place. One of the unique things that we're doing with the software is we have an architecture that we call conductor player, where every bot is essentially a discrete entity, and we have a computer that we're calling the conductor, and the conductor is sending out jobs and coordinating what each member of the orchestra is doing.
We want people to be able to use the parts in an end use case if they need to, or taking apart, printing it and casting it, or doing some other secondary process to it. My experience is really with kind of traditional manufacturing, and so machining or injection molding, and it can be days, weeks, months before you actually see parts in your hand. And so it's fun because what we're working on now, you design a part that morning, and that afternoon you can have the part in your hand.
We've really dug into a lot of the problems that are holding back this technology. We've reapproached how the technology is thought of, how it's used, and we really believe that that's going to unlock a huge class of applications.
to be clear, Autodesk is not releasing a new 3D printer. The Escher system is software and control technology that can work with a new generation of 3D printing hardware. So to reiterate what the technology is, Project Escher is a parallel processing system where numerous independent extruders collaborate to make one thing. It's faster because whatever the job is, there are more workers on that job. It makes big things for the same reason. Many hands make light and fast work. And there's no compromise to detail because we're using proven extrusion and motion technology. Through software and control strategy, we're enabling the industry to build a fundamentally new class of printer architecture. What you saw in the video is Project Escher applied to FDM extrusion technology. Imagine this system applied to large aerospace or automotive parts or printed concrete structures. Because of the nearly infinite scalability of parallel control, very soon size will not be an obstacle. So once again, we're not releasing a new printer. Our role is to drive innovation and research and development and license technology to those who can use it. What we learned from the Ember printer and work with Origin Labs and others is that working closely and early with partners is a clear path to successful additive manufacturing. To that end, we're inviting industry to talk with us about applying this technology to manufacturing challenges. Thank you very much, and now I'll pass the mic back to Kim.
Thank you. Okay, so that's it. We're just about ready for questions and answers. So I'm going to have everybody come up here in just a second. But what you saw today is how Autodesk is driving innovation in additive manufacturing through investments in 3D printing with the Spark Investment Fund, through contributions of an open system, an Ember, and then a new development to allow people to build both big, fast, and detailed with Project Escher. All right. So Corey, Pierre, Chris, Kevin, can you guys come up here? And then we're going to ask Bill Dannon here from our PR team to be the master of the microphone.
Is this working?
That's perfect, yeah. Okay.
You guys want to stand in the front, show off your experiment? I'm sure everyone's first question is Escher a printer? Okay, so questions from the audience. I have the right mic.
I just have a question about this Ember printer, what it's printing. What are the limitations that we're talking about to reproduce this kind of speed?
So there are a couple of different limitations. A lot of them are basically around the geometries that you can print. So really, you have to use software to optimize your parts to be printed using this high-speed technology. And that's why it's really important to develop the connected ecosystem of software, hardware, and materials. Well, what's really going to unlock high-speed 3D printing isn't the machine or the materials. It's going to be the design software that's going to enable people to design parts that can be printed using high speed. So typically, things have to be lattice structures, and designing lattice structures is actually fairly complex when you have all your other design constraints to bear in mind. So generative design tools like projects that Autodesk have been working on, such as Dreamcatcher, within are going to be tools that are going to enable this kind of manufacturing technology.
Other questions?
Thank you. Hi, Kenneth Wong from Desktop Engineering Magazine. I think my question goes to Corey Bloom. The idea of Escher, is this about a software that takes a geometric form that you want to print and reinterpret it so that the machine knows how to print it with multiple nozzles, or are we talking about something else?
We're taking objects and we're dividing them into multiple parts and then sending those parts to different, essentially independent printers that can move independently about that part. And there's sort of job optimization or load balancing, as we call it, that makes every printer work as efficiently as possible to minimize the amount of time collaboratively they use to build that part.
Tom Framsky, Silicon Valley Watch and ZDNet. Who else is doing work in this area? Are you going to be taking on the R&D for the entire printer industry?
I'm assuming you're talking about Escher. We're not aware of anybody doing work in this area. Historically, there have been some people who've done gang milling, but we've been talking to people in the industry. Apparently, that hasn't happened for some time, and we're not aware of anyone else working in this part of the industry.
So what is the demand for this?
Anybody who wants to make big parts quickly.
So I'm Ron Miller from TechCrunch, and you made it clear. You made it clear that you're not making a printer. So I know that, but you have software that's designed for these enormous kinds of printers. Is there actually a printer manufacturer out there making a printer that will work for this software, or is this software looking for that piece of hardware?
It's an entirely new type of hardware. So currently, there are no manufacturers building these systems because these systems are, it's a new thing. The hardware is actually configured to the software instead of vice versa, which has been the traditional way that machines have been developed. You build the machine and you say, oh, how are we going to drive this thing? So we're going the other way around.
So you created a solution that there's nothing to implement that solution on quite yet. Is that
yes, but the technology is actually very, very standard technology. It's a 3-axis gantry system, which has been going on for, 30 years or 40 years. There's nothing new to it. It's just how you control those systems and how you physically put them together. It's kind of like, that thing, but put together like this. It's sort of easy for somebody who's good at building 3-axis gantry systems.
So essentially you're trying to innovate ahead of the industry and hoping that the industry will catch up. Is that fair to say?
Sure.
It's not a bad thing. I'm just trying to...
I would just also add, if you can hear me, that the very first example that Kim showed was the Airbus, the partition airplane. So we're seeing lots of demand for large 3D printed parts. So we're doing our part to get the software there, but we know that there's an industry need for it.
Just another question about the Ember. Since Autodesk is now in the hardware business, how is it doing against the other 3D printers in the market? Could you give any idea of market penetration or competition with MakerBot or anybody else?
We released Ember as a sort of reference implementation for our Spark 3D printing platform. So it was never intended to sort of dominate the 3D printing market. And we've been very pleased with the adoption of the printer in the sort of the spaces where people are innovating in research labs and innovative manufacturing companies.
Any other questions? I hope it's safe to say that all of our speakers can hang out. We have coffee and snacks and stuff, so if people want to chat individually, we can do that. I think we have until 10:30, so yeah. So thank you everyone for coming. Kim, do you want to say any closing words? You were so good as an MC.
No, just that, we'll be here. If anybody has any questions, we'd be happy to answer them. And again, I know that your time is very valuable and your schedules are very booked, so I do appreciate you taking the time to be here. And we're here, but also our PR team is available, for follow-up questions if there are things that you think about after.
And I will add one thing to that. And we have, we'll give everyone a link. We have a whole press kit with images and names and written material, so we'll give that out to you guys.
Don't forget the custom tags. We made custom tags. The origin team made custom tags.
Oh, yes. There. Pick up your custom tag. Thanks, everyone.